Hi, Srivalli.
Hi, Shanti.
So you are doing phase two presentation today for this solution, right? ITOPS.
Yeah. So this is a five-phase series. We already did the presentation for phase one. I'll explain you in the coming slides.
Sure,
This
sure,
is the phase two. Yeah.
sure. Go ahead.
Hi, I'm Srivalli. I have about 15 years experience in IT industry. That includes various roles. My latest experience being at Microsoft Redmond, Washington. Today, I'm going to demo about transforming IT operations, strategic plan for designing a chatbot with AI ops. So, like I said, this is a five-part series. The first part, um, I've already covered the first part where we have seen what the challenges of our current IT ops system is and how we can meet those challenges through AI ops. This is the second part. Let's begin with the agenda. Our agenda today is review of the phases, um, and then we're going to quickly recap phase one, which is tackling IT ops challenges through AI ops solutions. And then we're going to go ahead with the phase two topics. That's IT ops support workflow for issue resolution, support workflow for an e-commerce use case, challenges of traditional support IT operations, streamlining efforts and resources with AI ops, overall benefits of implementing AI ops and ML ops, justifying AI ops chatbot for IT support optimization, implementing the chatbot with Azure ML. Okay, a quick review of the phases in this series. First phase, which we already covered, is tackling IT ops challenges through AI ops solutions. I'm going to quickly review this in the next slide, but the next phase, which is the current phase, is strategic plan for designing a chatbot with Azure ML, designing and implementation of chatbot using Azure ML, and migration plan of Azure ML chatbot into Azure Gen AI. So today we are going to talk about strategic plan for designing a chatbot with Azure ML. And this is just a discussion of the plan or the strategy. The actual design and implementation, we are going to talk about that in the next phase. And the last phase is implement chatbot in Azure Gen AI. So first, recap of phase one, tackling IT ops challenges through AI ops solutions. So what we talked about here were the key stages and methodologies followed uh, for IT support and operations in traditional methodology. Most of the tasks were manual ticket logging assignment, incident detection reporting, root cause analysis after repeated incidents, and manual change approvals and risk assessments, limited automation. Now, challenges in traditional IT ops are manual workload, reactive approach rather than a proactive approach, error-prone processes, scalability issues, alert fatigue. Advantages of AI ops in IT support and operations, proactive problem solving, automation at scale, enhanced decision making, scalability. So the first part of this series demo can be seen at this link. I've included a link for that here. IT ops support workflow for issue resolution. Let's discuss what the support workflow looks like in general. The issue is either detected or reported by a user, oh, sorry, issue is detected or reported on the e-commerce website. Here we are discussing in the context of a e-commerce website. And that's the first thing to start with in the workflow. And then there is going to be a severity assessment. Either it's a SEV1, SEV2, or SEV3. If it's a minor issue, then it's a SEV3. And if it's a major issue, then it's a SEV2. And if it's a breaking issue, or if it's a major, it's more severe than a major issue. Like if it's an outage, then it's a SEV1. So if we went through the minor issue use case workflow, L1 support does the initial troubleshooting. The initial troubleshooting might be as simple as just restarting the server, or maybe if there is a password issue, then helping the user change the password, kind of things. Very basic troubleshooting steps. If the issue is resolved, then um, if the issue is resolved, then we go ahead, they go ahead and close the ticket. And if the issue is not resolved, then it's escalated to the L2 support. L2 support does a deep dive troubleshooting. And then it's the L2 support team that decides if there is a need for a development team to get involved. That's the product group. If the product group needs to get involved, then escalate it to the development team. And if there's no, if they don't need to be involved, and if there's just some further investigation that needs to be done by the L2, then further investigation by L2, and then go back and check is the issue resolved. And this is an iterative way. Most of the times, L2 does some quick fix or some changes to fix customer issue, and then L2 goes back and inquires the support to find out if the issue is fixed. If the issue is not fixed, then they try something else, and then they try something else. So this is an iterative process. And then um, if at some point of time they decide whether the development team needs to be involved in this, and then they escalate it to the development team. And then the development team does further investigation, and then fix they fix the issue and they deploy the fix. So they find out if there needs to be a deployment, and then they go ahead, deploy the fix to production and close the ticket. If there is no fix deployed, then development team continues working until the fix is made and deployed. This is for a minor issue. And then for a major issue, L1 support notifies L2 or L3, and then immediate escalation to L3 or specialized teams. Root cause analysis or urgent fix is made, and communication to stakeholders and users. This communication going to the users and the stakeholders, and then implement fix and monitor. And then see if the issue is resolved. If the issue is not resolved, then then the L3 team continues escalation, and then and the recovery plan. And if the issue is resolved, then post-incident review is made, and then the ticket is closed. So you can see there is a lot of there's a lot of iteration, and there is a lot of manual intervention here. A lot of these tasks can be automated. Support workflow for an e-commerce use case. Here I'm taking an example of a minor issue. Use case of an issue handling. User reports product images not loading. So this is a real-time example. Ticket creation and categorization happens, and then initial diagnosis by L1 support happens. And then is the issue replicable? If it is yes, then they replicate the issue and they access the logs and error messages, and then see if this is a known issue. If this is a known issue, they apply the fix from the knowledge base. And if it's not a known issue, they do further troubleshooting. And the troubleshooting could be like flush the CDN cache, and resync files. And then they recheck, are the images loading? They go back to the customer and then they check, are the images loading? And if they are loading, then they confirm and they close, and then they close the ticket here. And if the images are still not loading, then escalate to L2 support team. And here, if the issue is not replicable, then check user side issues. So here also there are going to be different logs that are specific to the user. Let's say they go to the user specific logs and they check what has happened, what all has happened, and what actions the user has taken. Um, and then they, if they find out, for example, if they find out something n- like the user's browser cache is interfering, or some user side network is interfering. Let's say there are some security policies that are preventing the images from loading, then they give the instructions to the users. And then they confirm with the user and they close the ticket. Now, challenges of traditional support IT operations. Let's take a look at what challenges are there here. Manual troubleshooting, like I said, there was a lot of manual process involved at the L1 and L2 level. Example, minor issues like product images not loading or user unable to log in require manual checks, like CDN status, password resets, taking 30 minutes to 1 hour. And then impact high operational load on L1 support with repetitive tasks. Complex issues escalate to L2, increasing time and resource demands. Escalation bottlenecks. Example, major issues like website outage or DDoS attack require manual escalations to L2, L3. Now, this is a major escalation. This is examples of major escalation, and the impact of that manual diagnostics and coordination slow down responses, leading to longer downtimes and increased costs. High effort in root cause analysis. Now, the first one that we discussed was SEF3. The second one is a SEF2 issue, and this is a SEF1 issue where the root cause analysis has to happen, where the severity of the issue is more than just one user. There are multiple users, which means some service is down or there's some outage somewhere. In this case, we are going to have to do some root cause analysis, what really happened. Issues like database server crash or session persistence failure requires hours of L2 and L3 analysis. And then impact is prolonged recovery times due to manual RCA, increased resource usage, and higher operational costs. Streamlining efforts and resources with AI ops. So how can we streamline these efforts, especially the manual efforts involved at the L1 and L2 level? Um, the current IT operations, so I've made some tables here to compare between the current operations effort and the AI ops or ML ops, enhanced operations. L1 troubleshooting. The traditional approach is initial investigation or minor fixes, and the effort involved here is 4 to 6 hours. And for L2 escalations, which is a major issue, there's going to be deep dives and handling escalated issues. And this is going to take anywhere around 1 to 2 days. And then the root cause analysis, which is, like I said, a SEV1 issue, identifying long-term solutions. Time varies. It's definitely more than just a couple of days. So the time varies and more resources are involved, and most of the times the product group is involved. AI ops, ML ops, enhanced operations for the same three kinds of issues. L1 task automation, um, automated issue detection and resolution. 10 to 30 minutes for a minor issue. L2 escalations, predicting and resolving issues. Effort is just some a number of hours in training the model. Root cause analysis, automated root cause analysis, time varies, and this is significant improvement over the traditional approach. Key takeaways here are 70% faster resolution with AI ops, 50% reduction in L2 escalations, and significant reduction in manual monitoring. Overall benefits of implementing AI ops and ML ops: effort reduction. L1 and L2 teams spend less time because of the automation in place, less time in troubleshooting, and predictive analytics and automation reduce the need for manual interventions here. So predictive analysis is a concept that includes the uh, machine learning models and the AI services that use the historical data to predict if there's going to be a failure somewhere. So the automations, we can use predictive analytics concept to do the automation. Resource optimization, AI-driven solutions allow for better resource allocation, enabling support teams to focus on more complex and strategic issues. Fewer escalations to L1 and L2. So when there are fewer escalations to L1 and L2 due to automated processes, um, they will be able to focus on more complex issues. And cost savings, reduced human resource allocation to manual tasks, which results in lowering operational costs. Proactive problems resolution. Instead of having a reactive problem resolution, we have the proactive approach here, which means, for example, predictive analytics helps you predict um based on the historical data. It helps you predict if there's going to be a problem. So that's a proactive approach. So we have a chance to fix the problem before the problem occurs and before the damage starts happening. Faster incident resolution, automation speeds up response times, ensuring quicker resolutions for both minor and major incidents, which in turn improves SLAs and overall system reliability. Justifying AI ops chatbot for IT support optimizations. There are a lot of ways AI ops can be implemented and they are applicable. There are a lot of areas within IT operations where AI ops is applicable and it can be used for optimizing the effort. Chatbot implementation is one of the places where AI ops helps. Automates routine L1 tasks. The chatbot manages tasks such as password reset, basic troubleshooting, and FAQs, alleviating the burden on human agents. Enhances response time. Automated responses lead to quicker resolutions for frequently encountered issues. Utilizes predictive analytics. The chatbot identifies potential problems early, preventing them from escalating into major incidents. Improves resource efficiency. By performing repetitive tasks, the chatbot allows IT teams to focus their efforts on more complex challenges. Generates cost savings. Automation lowers operational costs by minimizing the need for human labor or routine tasks. Reduces escalations. Chatbot resolves minor issues independently, decreasing necessity to escalate problems to L2 support. So a lot of these cases that are reported by users using chatbot can be resolved by the automation that runs behind the chatbot, where so a lot of these escalations don't need to hit L1 and L2 at all. Implementing the chatbot with Azure ML. So as I mentioned in our phases, so in this phase, we are going to discuss the implementation plan for implementing the chatbot with Azure ML. Okay, data preparation and pre-processing. That's the first thing. And why do we need this? Because we can use the existing ML models that are in Azure, but they have to be fine-tuned based on the context. Here, the context here, for example, in our current case, the context is e-commerce website. And they have their specific terminology and they have their specific words that have to be uh, used. So the ML model has to be fine-tuned based on those terminologies. So we need to use the incident data and the knowledge base for fine-tuning the ML model. So that's the first step. First step is data preparation and pre-processing. Text pre-processing, we need to tokenize, clean, and vectorize the text using techniques such as removing stop words, stemming or lemmatization, TF-IDF or word to vec for vectorization. Model training in Azure ML, um, intent classification model, um, build an intent classification model using Azure ML. Use labeled incident data where each query corresponds to a specific intent. For example, check order status, return policy. Train using supervised learning algorithms like logistic regression, SVM, or random forest. Entity recognition. For identifying key entities like order IDs, product names, etc., build an NER entity recognition model using Azure ML. So NER is named entity recognition model. Is a type of NLP task where model identifies and classifies key entities in a text into predefined categories. So, for example, there are specific terminologies which we can refer to as entities like order IDs, product names, dates, and locations. These are very specific to an e-commerce website or e-commerce application. And the model needs to be trained for these entities so that it can recognize when a user types types their queries. Um, the model behind the chatbot can recognize what the user is referring to. And then knowledge-based search model, use a traditional information retrieval model, example TF-IDF, cosine similarity, to fetch relevant responses from the KB articles. Train this model to rank responses based on query similarity. Now, deploying the ML model deployment, once trained, deploy the intent classification and entity recognition models using Azure ML endpoints. The deployed models will be accessible via REST APIs, which the chatbot can call to classify user intents and extract entities. And next, the chatbot integration. We can use the Azure bot framework to create a basic chatbot interface, which can accept user queries and send the queries to the automation that runs behind the chatbot, which is the Azure ML-based intent classification model. Um, And then if the query matches an intent related to knowledge base article, the bot will call the information retrieval model, return the response to the user based on the top ranked KB article or the incident record. So it's going to correlate. So the database is incident database and also the KB articles. We are going to use both kinds of data here, um, which are so when there is a query coming in, the ML model is going to correlate, is trained to correlate the KB articles with the incident records to come up with a solution or to come up with the answer. Testing and iteration. Test the chatbot for accuracy in intent detection and entity recognition. Refine the model based on user feedback and interactions. Chatbot with Azure ML. So this is the Azure bot service framework that we can use for building the chatbot. So this is the chatbot. This is the user that interacts with the chatbot, and the chatbot that is built with the Azure bot service. And that basically at the back end interacts with the Azure ML intent classification model and also with the ML NER model. Um, and then so the intent classification model identifies the user intent, and then the NER model extracts the key entities, and it decides what the intent type is, and based on what the intent type is, as your cognitive search or the Q&A maker is called into is one of these two cognitive services. As your cognitive search or Q&A maker is called, and then as your cognitive um, sorry and then intent type is matched with the incident database, and so which retrieves the past incident solution, and then it gives the answer to the Azure bot service, and then the Azure bot service sends the response to the user. And then here in this case, in the case where the cognitive service is used, it retrieves the relevant KB article and it returns the answer to the bot service. And same thing, it sends the response to the bot service. Via bot service, the user gets the response. So basically, we are using either the KB article or the incident database. So based on the intent type, um, if the intent type matches the one in the incident database, then we go this path, and then if it matches through the such cognitive service, then um, it's gonna retrieve the relevant KB article, and then it returns the answer. Yeah, that's the end of the
So
presentation. Thank you.
this flowchart gives you direct solution to connect to the database, incident database in live
Yeah,
with bot services.
yes.
But in your presentations, in your phase 3 presentations, you are going to prepare the data and going to work and fine tune the data with data bricks also. There is a process before starting this flow, data flow
Okay.
for chatbot services, right?
Yes. Yeah,
So you
that
are
is
going
the
to work
data
on that.
preparation. Yeah, that's the data
Yes, data
pre-processing and the
preparation and
preparation.
running data bricks to fine tune the data,
Yeah,
right? So that you are going to show in your phase 3 presentation, right?
yeah,
All those, so,
yeah. The
right?
actual implementation plan is going to be in the phase 3.
Yes, including data preparation, I am saying,
Yeah,
because you
yeah,
need to show that also.
yeah.
Okay, okay. I'll stop recording.